this video of a person having a seizure. It was published as part of a paper. We'll go over the paper later on, but let's actually try something hopefully interesting. So the video has the EEG on 20 something electrodes, 1020 EEG, pretty standard stuff, and we have a video of a patient as well. Now we will see how an AI agent, a Gemini to be more specific, is able to review this video. But what we will do is we will actually hide the video, and we will get the AI agent just look at the EEG alone. Well, we'll try to see if you can actually explain what is it we are looking at. Might just get rid of the video. Get rid of the video, and we'll start it in the beginning. The video doesn't have audio. Okay, it has some weird thing in there. Okay, so we have the video starting about here. So we have this. Actually, yeah, let's start it from here. And let's bring in an agent. We'll share the screen with Gemini. Let's see how we go. Share this video. Okay, can you see the video? Can you see the video on the screen?
Yes, I can see a video. It looks like it's displaying EEG readings with various lines representing different brainwave activity.
Okay, one sec. I'm actually having trouble with my audio. One sec. Okay, let's start again. Let's start again.
Yes, I can see a video. It looks like it's displaying EEG readings with various lines representing different brainwave activity.
Okay, nice. Can you give us a bit more details as to what the recordings are?
The recordings appear to be electroencephalogram data, or EEG, showing brainwave activity. There are multiple lines, each representing different electrode placements on the scalp, capturing electrical activity from the brain. The lines are displaying various wave patterns, which can be used to assess brain function. Additionally, at the bottom of the screen, there are lines showing EKG readings, indicating the heart's electrical activity.
Okay, and what's MKR plus, MKR minus, do you know?
The MKR plus and MKR minus indicators at the bottom likely refer to markers or events identified in the recording. These markers might be used to highlight specific points in the data, such as significant wave changes or events that occurred during the recording. They help in analyzing the data more precisely.
Okay, so I'm playing the video now. Can you explain what's coming? Can you see what's coming in the video? What's happening now?
The video is showing the EEG readings progressing over time. There are some changes in the wave patterns, particularly in the red lines at the top, where the waveforms become more prominent and irregular. This could indicate changes in brain activity. The EKG readings at the bottom also continue to show the heart's electrical activity.
Yeah, and can you predict what's happening? So if you had a video of the patient having this EEG recording, what will be happening in the video?
If a patient were having a seizure during this EEG recording, you would likely see significant changes in the brainwave patterns. There would typically be abnormal, synchronized, and high-amplitude electrical activity, often appearing as sharp spikes or wave discharges across multiple EEG channels. These patterns are indicative of the chaotic and excessive electrical activity in the brain during a seizure.
Okay, can we stick to the current recording that you see on the screen? The squiggles there, the larger activity, the darker regions, what do you think they are? Assuming you are an EEG expert, what are they?
Based on the current recording, those larger wave patterns or darker regions could represent various electrical activities. They might be artifacts, such as muscle tremors or eye movements, or they could be significant brain activity, like epileptic discharges, depending on their shape and location, or even normal brainwave patterns during specific states of consciousness. A detailed analysis by a trained expert is necessary to interpret them accurately.
Okay, can you just pretend for this exercise to be an EEG expert? Can you tell me where my mouse cursor now, hopefully you can see my mouse cursor, is this activity EMG or not?
Based on the movement of the mouse cursor and the appearance of the activity in that region, it looks like it could be EMG artifact. EMG, or electromyography, reflects muscle activity, and it often appears as faster, more irregular waveforms compared to brainwave activity. The characteristics of the waveforms in that region are consistent with muscle activity rather than brain activity.
Okay, let's move on. So let's assume this is muscle. What's happening right now as the signal progresses, as the recording progresses? Can you also mention the difference? What do you think the difference is between red and blue recordings?
As the recording progresses, there are various changes in the EEG waveforms. You can see some increased activity in both the red and blue recordings, with more prominent wave patterns appearing. The difference between the red and blue recordings likely represents different electrode placements on the scalp, capturing brainwave activity from different regions of the brain. The variations in the wave patterns between these channels can provide information about the spatial distribution of brain activity.
Okay, and can you be more specific? What's the difference between red and blue?
The primary difference between the red and blue recordings appears to be the location of the electrodes on the scalp. Different electrode placements capture brain activity from different regions, leading to variations in the waveforms observed. The red channels might be recording from frontal regions, while the blue channels might be recording from posterior regions or other specific areas, resulting in the different wave patterns you see.
Okay, for the sake of this exercise, can you be very, very specific? So you're like an absolute expert in EEG recordings. Can you look at the labels of each channel and tell again exactly what's the difference between red and blue?
Based on the channel labels, the red recordings primarily represent activity from frontal and temporal regions on the left side of the scalp, such as FP1 to F3, F3 to C3, C3 to P3, and FP1 to F7, among others. The blue channels, on the other hand, capture activity from central and posterior regions, including C4 to P402, FP2 to F8, and T8 to P8, among other locations. The differences in the waveforms are due to the distinct brain activity patterns picked up by these varied electrode positions.
Okay, that's very nice. What's the current, again, looking at the labels of each channel, what's the current montage that is being used? Can you explain what it is and just make make a guess which montage is being used?
Based on the channel labels, it appears to be a longitudinal montage, also known as a referential montage. In this montage, each channel records the difference in electrical potential between two adjacent electrodes in a specific chain, or line, relative to a common reference. This configuration allows for the assessment of brain activity across different regions, emphasizing the electrical gradients between electrodes.
Okay, this is really nice. So I'm playing the rest of the video. What's currently happening? What's coming in the signal? Can you again continue pretending being an EEG expert and tell me what's happening?
As the recording progresses, there are some significant changes in the EEG signals. You can observe periods of increased amplitude and frequency in both the red and blue channels, which might indicate increased brain activity or artifacts. There are also some brief episodes of more rapid, high-amplitude waveforms, particularly in the red channels, which could suggest specific brainwave events or muscle artifact. The blue channels also show periods of increased activity, sometimes with more distinct wave patterns. Overall, the signal So, in this longitudinal montage, you're seeing the electrical potentials measured between neighboring electrodes, which helps to localize brain activity along the scalp. The different patterns in the waveforms reflect the varying electrical activity generated by different brain regions. This type of montage is useful for identifying the spatial distribution of brain activity and can be helpful in detecting abnormalities in specific regions.
Okay, and what do you think we are mainly seeing? What's the signal indicates?
The signal indicates various brainwave patterns along with some artifact, likely muscle activity. The different waveforms in the different channels suggest varying brain activity across different regions of the scalp. The presence of faster or regular activity, particularly in some channels, indicates the presence of muscle artifact.
Okay, I'll keep playing the video. Can the next screen? What's happening now? Can you indicate the details and also the difference between the different what's happening on what's specifically happening on different channels? What's the difference is?
From the video, I can see different brainwave patterns evolving across the various channels. Some channels show more rhythmic and organized activity, while others display faster, more chaotic waveforms, which could be due to muscle artifact or different brain activity states. The variations in amplitude and frequency across the channels indicate localized brain activity patterns. The longitudinal montage allows for comparison between adjacent electrodes, helping to pinpoint the source of these activities.
Okay, I'll keep playing the video. What's happening now? Is it mainly muscle or is there something else going on?
It appears there's a combination of muscle artifact and brain activity. The very fast, irregular waveforms in several channels are characteristic of muscle artifact. However, there are also slower, more rhythmic patterns in other channels, which indicate typical brainwave activity. It's important to differentiate between these two types of signals to accurately interpret the EEG data.
Okay, I keep playing the video. What's coming? Can you tell if potentially there is no more EMG? Is there anything else going on? Can you tell?
From the video, it looks like the muscle artifact has significantly decreased or is much less prominent now. The brainwave patterns appear more rhythmic and rhythmic. There might still be some subtle activity, but it looks like the focus is more on the brain's natural electrical activity now. It's important to continue observing for any changes or anomalies in the waveforms.
Okay, that's a bit weird. Wait a sec. So can you look at this time period, time window over here, and what difference does it make compared to this image here? What difference are we seeing? So second 12 compared to second 1 minute and 40 seconds. What's the difference between the two states?
Comparing the time periods, the earlier segment showed more significant muscle artifact, characterized by fast, irregular waveforms, especially in some channels. In the later segment, the muscle artifact appears reduced, and the brainwave patterns are more regular and discernible. This suggests a clearer view of the brain's underlying electrical activity with less interference from muscle movement.
Okay, let's keep going. We'll play it from this point onward. Can you tell what's going on? What's happening here and what changed?
Based on the current view, the EEG activity appears to have calmed down significantly. The waveforms are much more regular and less erratic, indicating a reduction in muscle artifact and a clearer recording of brain activity. It looks like the person is now in a more relaxed state, compared to the earlier segments with more noise and movement.
Okay, except noise, is there anything else going on in the signal? Can you keep looking at it? And is it baseline? Do you think it's baseline or not?
Yes, based on the reduced noise and more regular waveforms, the current signal appears to be a much cleaner baseline recording. It seems like the person is in a relaxed state with minimal muscle movement, allowing for a clearer representation of the brain's intrinsic electrical activity.
Okay, are you able to tell what the frequency of the brain activity, say, on the bottom channel there?
The brainwave activity on the bottom channel appears to be in the alpha range, typically between 8 and 12 hertz. The waves are relatively rhythmic and organized, which is characteristic of alpha wave activity, often associated with a relaxed but awake state.
Are there any artifacts in the signal?
No, in this current time window, the signal appears relatively free of artifacts. The earlier segments had noticeable muscle artifact, but the current view shows much cleaner brain activity with minimal interference.
Except the muscle artifact, are there any other types of artifacts? Also, what have changed now?
Besides muscle artifact, there aren't any significant other types of artifacts in this view. The signal is now much clearer, and the primary brainwave activity is more discernible. The change is mainly a reduction in noise and a cleaner recording of the underlying brain activity, suggesting a more relaxed state of the subject.
Okay. Are you sure about that? Are you sure it's baseline and nothing else is going on? Can you double check? Well, there is muscle now, but before, was there anything happening before?
You're right. Looking closely again, there was a brief period of increased muscle artifact just before the current clean segment. It seems the baseline recording was interrupted by some muscle tension, but now the signal is much clearer again. Thanks for pointing that out.
Okay, that's interesting because essentially it was not able to make a diagnosis. Yeah, which is quite interesting. Quite interesting. Yes, so I wonder what it will able to do if it had the video of the patient as well. But then some things are pretty obvious. Should be pretty obvious. If we hide the patient again. Let's extract two images real quick. Let's extract, yeah, this one, which meant to be baseline. Then we have some muscle, and then we have this one here. Should be fairly obvious what it is. Let's see if another model can get it right. One sec. So we have, let's do this too.